we're going to talk about finding the area of between two graphs. And then we're going to talk about finding the volume of the solid if that area is the base of a three-dimensional figure. So to start with, when you find the area of a region like P here, you always integrate the top function minus the bottom function. Okay, so that's an integration. Probably I should do that smaller. Let's try again. So we always want to do, and this is in terms of x. Okay, notice that these are perpendicular. When we look at part B, this region is the base of a solid, and the cross sections are perpendicular to the x-axis. So what I want to do is draw a little rectangle here to get ready for that, but it's going to help us with this first question too. Because these are in x, that's the height of this region. And you'll notice that the width of this rectangle is dx. It's the change in x. And that's going to become very important. Okay, that's the width of that rectangle. And then we're going to take that rectangle to find this area, and we're going to slide it from here at 0. Okay, so just pretend like we're sliding this, not making a new one. We're going to have a little tiny rectangle here, top to bottom at 0. And then when we slide it over to here, our rectangle is going to be this tall. And then when we get over here, our rectangle is going to be small again. And the height of our rectangle depends on what x is, because that tells me how tall the top function is and how low down the bottom function is. So this is the height of each rectangle. The height changes as the functions change. Okay, but this height is given by the top function, which is the square root of x, minus the bottom function, which is x squared minus 4x. And notice, if x is 0, our height is 0. And we want to go over here to this x where they meet, which means we need to find where does f of x equal g of x. And so that's how we're going to find this point right here where the two functions meet. Okay, so f of x is the square root of x and g, that has to equal g of x, which is x squared minus 4x. Now, if you put the square root of x on this other side, you get 0 equals x squared minus 4x minus the square root of x. Now, I don't know if your teacher will let you solve that on a calculator, but I'm going to solve that on a calculator. I am going to graph it. Okay, I am going to graph x squared minus 4x minus the square root of x. And This is the picture that I get. Okay, then, oh, so now that I have that, I know that when y is 0, that'll be the x where these meet. So if x is 0, y is 0. Clearly, that's this point here. But I need this point. So I'm going to ask my calculator, gsolve, to find the roots. First one's at 0. The second one, if you can see it, I don't know if you can read that, but it tells me that it is at 4.4728. $339. Now, I solved this a different way. Right up here, I squared both sides and then moved the squared over. And when I solve that as a polynomial, I might be able to get a more exact. So let's go to, I forget how I solve a polynomial. Here it is, equation. Polynomial, degree 4. And when I do that, I get x to the 4th minus 8x cubed plus 16x minus x plus 0. No constant. Oh, there it is. And I don't get rational numbers. So that may be as good as we can do. Although I could graph it and see if I get better. But anyway, this is where they meet. So the area is the integral top function minus the bottom function, because that's the height of each rectangle, and then you need the limits of your integration. And remember, we start by making these little rectangles. We start them at 0. And we just figured out that they're going to quit here at this 4.4728. And I'm guessing that your teacher will let you, or your professor will let you do this on your calculator. So when I do that, I have to go to where do I go? I forget. Equation. No, exit. That's not it. I need calculus. I need to go menu. Up here to run. I need to go math. I need to integrate. Here it is. Okay, so I'm going to integrate the square root of x minus parentheses x squared minus 4x. And I'm going to go from 0 up to 4.4728339. And when my calculator does this numerically, I find that the area of P of that region is 16.4907. Yeah. This is 16.0. Nope. 0.4907. I don't know how many decimal places your professor wants or your teacher wants. Okay. Now, if this is the base of a solid, basically what we're going to do is we are going to show that really what I have here, that's not how I want to do it, that really what I have here are these squares that are coming out of this base. You'll have to use your imagination here. So the height of each square here is the same as the height of these little rectangles. So a square, the area of each square is side length. We'll just do this. It's the length of a side times the length of a side. And so for this square, the area is the base height, which is the square root of x. I'm going to distribute the minus sign. Minus x squared plus 4x times that same length, which is the same thing as saying we're going to square this. Right? It's the side length squared. So when we're doing the volume of a solid, we are doing the integral of the area of one square, the area of one of the cross sections, and it has a width still of dx. Okay, so we're still starting at 0, and we're still going to 4.47, etc., etc., etc. Only now, we're not looking for the area of this region. We're looking for the volume of what happens if I put a whole bunch of squares. And remember, the bottom length of this square is the same as a side length of this square. And so the area of each square is just this length squared. And we're going to take that area, and we're going to take it times this little tiny dx, and then we're going to run them again from 0 all the way over to this 4.4728339. So this time our integral is going to be, we're still starting at 0 and going to the 4.472839. But this time we are taking the side, each side, and it's the side squared that gives us the area. And then we go dx, and that makes it a volume. Now, I'm assuming that your teacher, once again, will let you put that on your calculator. So if I put parentheses around this and parentheses around this, I'm going to have to start over. Clear. Okay, let's try again. I am going to integrate the square root of x minus x squared plus 4x, that whole thing squared. And that is going to go, same limits, from 0 to 4.4728339. Oh, I got an error. I got to change this. Square root of x minus x squared plus 4x squared. Now let's see if it'll take it. Okay, I got to change what I do. So let's just multiply and type it again. Square root of x minus x squared plus 4x. No, I still have an error. I think I know what it is. I need another parenthesis. Now it should work. And this time I get the answer of, on my calculator, I get 72.0575. And if they haven't given us units, you can say that this is square units. No, this is cubic. Okay, because it's a volume. This is a volume. So this is going to be cubic units. And on your answer up above, that was an area, so this should have been square units. I don't know how picky your professor or teacher is. But you could say this is square units, and you wouldn't be wrong, and you might actually save yourself a point. Because area is square units, volume is cubic units. Thank you.